Okay, so this is 2014 question 1, and it says grass clippings are placed in a bin where they decompose. For 0 to 30, the amount of grass clippings remaining in the bin is modeled by this function, where A to T is measured in pounds and T is measured in days. A asks, find the average rate of change of AT over the interval 0 to 30, indicate units of measure. So you're just taking the average rate of change. So it's A of 30 minus A of 0 over 30 minus 0, which would, if you plug it in, you would get 5.904 over 30, which equals negative 0.197 days.
Pounds per day.
Pounds per day, yes. That's right. That looks really ugly, but you know what I mean. Okay, and then B asks, find the value of the derivative at 15 using correct units. Interpret the meaning of the value in the context of the problem. So you take the derivative, and you need to know this property in order to do this problem. D over dt of A to the U equals ln of A times A to the U times U to the 1. E prime. And in this case, e to the prime would just be 1. So then you would do the thing, and you would get A prime of t equals 6.687 times ln of 0.931 times 0.931 to the t. And then you take the derivative at 15, and you would get 6.687 times ln of 0.931 times 0.931 to the 15th. And if you plug it into your calculator, your final answer will be 0.16359. Negative. And so if you write it out for the thing, it would be the amount of grass in the bin is decreasing at a rate of 0.16359 pounds per day of time equals 15 days. Okay. There we go. And then for C, it asks, find the time for which the amount of grass clipping in the bin is equal to the average amount of grass clippings in the bin over the interval 0 to 30. So you just do the formula, 1 over b minus a, the integral from a to b of the function d of x, and when you plug it in, you'll get 1 over 30 from 0 to 30, a to t, which is our function d of t, and you can just plug this into your calculator, and you will get 12.415 days. And now for D, it says for t is greater than 30, L of t, the linear approximation to A at t equals 30, is a better model for the amount of grass clippings remaining in the bin. Use L of t to predict the time at which there will be 0.5 pound of grass clippings remaining in the bin. Show the work that leads to your answer. So first, we know that A of 30, if you plug it into the equation, is 0.783, because they give us the coordinate 30. Well, now you know that, 0.783. Okay, and then if you take the derivative at 30, you will get negative 0.056, which will be your slope, and then you put it in point slope form, and I'm going to be using L of t and t. L of t was 0 minus 0.783 equals negative 0.056, which is our slope, t minus 30. And then you can solve for L of t, and you will get 0.056 plus 2.463. And then we know that L of t is 0.5 because that is what they gave us in the problem. So you can plug in 0.5 equals negative 0.56 t plus 2.463. And then if you solve it out, you'll get time equals 35.0536 days.